All right, so now this comes up a lot, partly in recursion. If you know recursion, you get, I give an input to a smaller input to my friend, and she gives a smaller input to her friend. And then what's the base case? Well, my favorite base case is 0, right? What's 0? You can have the 0 integer, you can have the empty set, right? You can have the empty tree. These are all things that I really like. So here we have the statement that every elephant in this room is pink, right? So what do you think? Is this true or not true? Right? You have to, sometimes when you're working with the base case and you want to say what answer should I give to this base case, the one way to go about it is saying what's actually true. But another way about it is saying, well, if I'm the guy given this base case, what answer do I need so I get the right answer, right? You can do that as well. But anyway, we're going to go with yes, right? You look around, what's its negation, right? Its negation is that there exists an elephant in the room that's not pink, right? Is there an elephant in the room that's not pink? No, there's not, right? So here, let's look at again, the various cases. Every elephant in the room is pink. Some elements, some are pink and some are not. Every elephant's not pink, right? I don't know where we're going here. So I don't see any pink elephants in the room, right? So this statement is false, right? There definitely doesn't exist an elephant in this room that's not pink, right? That's definitely false. And so we need to make the other true. Right? Everybody good with that? Now, people are nervous about it. And why are we nervous about it? All these statements down here assumes that there are elephants in the room, right? And so let's have a new case in which, right here, there are elephants in the room and they're all pink, right? These are all, there's elephants in the room. And here's a new case where there's no elephants in the room. And that's the universe we happen to live in. And in this universe, there are definitely no elephants in the room, right? So we're gonna make that true, right? What is that thing up there? Right. So as I said it for recursion, but it can also be for loop invariance. If you know what a loop invariant is, at the top of the loop, you have something that's true, always true. And here, the loop invariant we want is that every elephant in the room is pink. So let's kind of, right? How do you do loop invariance? You have to say, somehow you have to establish the loop invariant at the beginning, right? If the precondition's true, right, you got an input that you like and you do this code, then we can establish the loop invariant. And how do you maintain the loop invariant? Well, if the loop invariant's true and you do this code and you're not exiting, you do the code, you can maintain the loop invariant. And then you get the postcondition. All right, so here's some a little bit of code, right? We're gonna elephants arrive, and if what are we gonna do in our loop? If an elephant arrive and it's pink, then we stay happy, right? Otherwise, we crash out and we go home, right? And this is kind of a hint here. when we first, what value do we want to set our flag to be at the beginning? Right? I mean, so here, as elephants arrive, right, we're maintaining the loop invariant. They were all pink. A new elephant arrived. It's still pink, right? Oops, it's not pink anymore, right? So now we want to think, how do you start the code? How do you establish the loop invariant, right? Well, when we establish the loop invariant, there are no elephants in the room, right? So do we want to set the flag to be, say that they're all pink? Yeah, we do, right? Because if we set the flag that they're not all pink, then we're going to crash out of this loop, right? So that's, again, just sort of arguing, right? Everybody good with that? And you're going to, this is going to come up when you're doing iterative algorithms, recursive algorithms, so it's good to know.